3, 2, 1. You're watching Virtual Jug, and with you am I, Alex Life. I will be hosting this Virtual Jug session. Virtual Jug is the Java user group taken online, the virtual one, and I'm happy to see all of you here, and I'm happy if you're just watching the replay on YouTube. Today, we have an excellent opportunity to learn from the best, as our host today is Marcus Biel. Marcus, how are you doing?
Hi, Oleg, how are you? I'm fine.
I'm pretty good. It's been a rough couple of days weather-wise in Estonia. Spring doesn't want to come still, but we'll manage. We'll manage. It's a good weather to educate ourselves. So we are live. I'm sure the YouTube video is fine. The stream is fine. If there's any problems, you should tell us in the chat, in the live session channel on the Virtual Jug Slack. And before we start, I'll just want to say a couple of words, like the organization things. Right, let me share the screen. I'll share the screen and I click play on my keynote, right? You can see this. Right, so today's session is Java Turbocharged. It's a session about Quarkus, the Java stack, and it is led by Marcus Biel. And you can follow him on Twitter, obviously, and he will be happy to answer all your questions about technology. Marcus is the Director of Development Experience at Red Hat, a software craftsman, and he wrote a book or several books. So he has experience and things to share with you. So follow him, ping him, ask him questions, and learn from him. And if you have any questions about the Virtual Jug, or if you have any feedback or suggestions, please share that. Ping us on Twitter at Virtual Jug or directly to me at Shalaf. And we're gonna gather all the questions about the session. If you want to ask Marcus questions, you can join the Slack channel and join the live session channel and ask questions there. And I will wait for the opportune moment and deliver your question to Marcus. If the quality of the video is not up to your expectations, this is not us. This is most probably your YouTube widget. So use the cog icon near the video to raise the quality. It should go up to HD. So with all those two quick questions out of the way, some organization, right? We are back to the session. So Marcus, you're here. You're going to talk today about Quarkus. And if you have any questions, if you want to ask something from the audience, I'm here. The chat is here. And we are here to learn from you.
Okay,
the stage is yours, and please take it.
Okay, thank you. So to everyone, I hope you're in the chat, because we'll have some questions which you can answer in the chat. So now I will directly share my screen, and we can start. Let me know if you can see my screen, if everything is fine.
Yeah.
Can you see it?
Yes,
okay.
I can see the slides, and I can see the title slide.
Okay, so this is my talk now, so let's start. So first of all, as I said, I want to start with having a question for all of you. So do you know when Java version 1.0 was first released? Can you tell me the year? Please type this in the chat if you know. Anyone?
Let's hope there will be some answers in the chat.
Okay.
I can take on this one, maybe. I know I'm older than Java, so I should know when it appeared, but I'm blanking on the exact year.
Oh, there is one, 95. Okay, 95? That's close. No, not 95.
I'll vote for 95 as well. But are you asking about the actual release 1.0?
Release of 1.0, exactly.
Or release candidates?
Release of 1.0. 92, no?
I think Python was 90, no? I will not hijack this conversation any further. I admit I know.
No, 96, yeah, Kleber knows it. Yeah, thank you, Kleber. That was the exact same date, so it was 1996. So, wow, that's a long time, right? I mean, some of you might not even have been born at the time. So let's now go back in time. Let's go on a little journey to remember what this time was like. So at the time, we would have had computers, assuming you're born at the time already, like this, right? Super sexy computer with a monitor as chunky as this one here. I don't know if you can see my pointer. Somehow it's failing. So anyway, And a typical computer at the time, yeah, exactly, 23 years, Scott, that's correct. So at the time, a typical computer would have had, for example, a Pentium with 133 megahertz, right? No giga there. And for example, memory-wise, we would speak of something like 8 to 32 megabytes of RAM. So again, no giga there, quite different. And if we would be speaking of application development, right, at the time, we didn't have agile or fragile, right? And so we would develop on an application over months, sometimes even for years. Well, for some companies, that might still be the case, but that's a different story, right? And well, we wouldn't also have any testing at the time, at least not the way like automated testing that we know it today. And yeah, so the whole pace would be much, much slower. And a typical computer also would have just one CPU with one core. And the server, so you would have running your application on the server, and you would probably not share it even with other applications typically. Yeah, and this is the time when Java was first released, right? So obviously this has some influence on Java. So Java was perfectly optimized for long-running processes. So because of that, it wouldn't matter. Like imagine your application needs like several minutes to start up, wouldn't matter, because as soon as finally after months or years our application was on production, it would most probably also run on production for like a long time, maybe weeks or even months, right? And because of this, if your application needs a few minutes to start up, this didn't matter, as long as after this it would run super, super fast. And it did. But now fast forward, right? Today, Java is in the cloud. The cloud is a big thing. We have smartphones, we have social media, like we are online 24/7. And back then, we only had like not even 1% of the population of the world population online. Today, we have 56% online. So it's like many, many more people are online, and we're doing much more, and we have smartphones. So it's very different. The pace has changed a lot, right? And well, but how is Java performing here? And there, and especially in a serverless environment, things are a bit difficult for Java, because Java, as I said, was optimized for long-running processes. But specifically in a serverless environment, the pace is so fast. We would have like when there's a spike in the requests coming in, we would really quickly have to spin up several containers in a multi-cluster environment. And when the spike is gone again, we would want to spin them down again, right? As aggressively as possible. If possible, even down to zero, so we can save a lot of money. But if your container needs several minutes to heat up, this might not be possible, right? And this is why many companies have started to move away from Java, unfortunately, and towards Go or Node. But we at Red Hat, we really love Java. And obviously, we have lots of applications written in Java. So we were trying to find a way of how we can improve that. Because, you know, Java was said to be dead like several times already. And still, it keeps going forever. And this should stay like this forever, right? So we were looking, what can we do? And this is how Quarkus was born, supersonic Java. So now let me show you what this really means. Okay. So to better understand why Quarkus makes me so excited, I have here this graphic for you, right? And I want to, in this graph, I want to compare Quarkus. Okay, so we have three different things here to look at. So first of all here, we have Quarkus running on GraalVM as a native executable, right? Second, in yellow, we have Quarkus running on OpenJDK, for example, the hotspot VM, right? And third, we have a traditional cloud native stack. Now, what is a traditional cloud native stack? Maybe anyone in the chat can guess that? Okay. Anyone in the chat?
It's when you run it on JBoss. I know an application server called JBoss.
Yeah, JBoss, for example, or Tomcat, exactly. It could also be Spring Boot. It could be Wildfly, you know, whatever. All these kinds of servers, that would be what we mean when I say traditional cloud native stack. Okay. So now let's see, right? What does this mean memory-wise? And when I say memory-wise, I mean memory RSS, which means the entire memory that the application is using, right? I mean, very often we just look at the heap size, but heap size, I mean, that's interesting, but it's not everything, because like especially in the cloud, we care about the RSS memory, the entire memory the process is using, because after all, that is what we pay for, right? Because, which is also funny, if you look back at the time, we only had like in 1996, we had like 32 megabytes of RAM. Now we have gigabytes. But the funny thing is, memory these days is way more expensive than back then, because, well, we are in the cloud, we're in a multi-cloud environment, we have to share everything, right? Sharing the CPU is super easy, but sharing the memory is not so easy, right? And this is why we have to be really careful with the memory and try to use as little as possible, because if you want to spin up, let's say 100 containers, this easily multiplies like crazy. So now let's see a typical REST application here. Here, for our traditional cloud app, we would typically use, for example, 140 megabytes, possibly more, just example numbers. And here for Quarkus running on a hotspot VM, that would use just 74 megabytes. So this is about half the size, right? And if we're speaking of Quarkus as a native executable, we go as low as 13 megabytes only. So this is not even a tenth of the size of our traditional app, right? So this really, I think, is just mind-blowing, right? And if you look at REST and CRUD, for example, JPA, that could be similar numbers we have here. For example, 35 megabytes for Quarkus as a native executable, 130 megabytes for Quarkus on OpenJDK, and 218 for a traditional cloud native stack. Okay. So next, I want to look at the boot time and the first response time. So first of all, we have to clarify what actually is the first response time, right? So when you have your war or jar, you have to deploy it to your server, right? And then this takes a while until this on the console is reporting to be running up. Very often, however, the frameworks are usually lazy loading. So even though the server might report you that it's up, it might actually not be entirely up, because only when the first request comes in, only then the hotspot VM will perfectly heat up, and this will take a while until everything is ready. So the first response might take a while for a traditional cloud native stack, right? And if we look at this in a REST environment, we will see this could typically take 4.3 seconds, right? Which is a super awesome fast thing, especially if that happens in like 1996. But in a cloud environment, specifically in a serverless environment, that might just be too slow. Okay, because imagine you have a user, you just were spinning down your applications down to 0 because there was no user at the moment at the website. And now a user comes and you have to tell the user, oh, you have to wait for 4.3 seconds until you will get an answer. That was probably too slow, right? Now, if we look at REST and Quarkus, on Graal VM, we will see this is just 14 milliseconds. And I will show you in my coding demo, which we'll do in a sec, this can even be like 6 milliseconds or faster, right? And again, I think these numbers are just mind-blowing. But, I also have to say, like, you can use Graal VM, but you don't have to. Quarkus is awesome both on the OpenJDK as well as on Graal VM. So, Graal VM has lots of advantages, but it also comes with a few restrictions. And the question is, are you ready for Graal VM or not? There are companies, for example, I think I know Twitter. They are running already on Graal VM, so you might also. I think should be, like in the average case, it should perfectly be possible, but you have to check. And if you want to run Quarkus on Hotspot VM, that's perfectly fine too, right? The numbers with not even a second, 75 milliseconds, that's just mind-blowing as well, okay? And now for REST and CRUD, the numbers are very similar. So here we have 55 milliseconds for Quarkus on Graal VM, 2.5 seconds for Quarkus on OpenJDK, and here 9.5 seconds for the traditional cloud native stack. For example, Tomcat or Jetty, right? Or Spring Boot, whatever you like. Okay, so now I hope that much, okay? But how is this actually working? Now is the biggest question probably. Okay, so let me explain. So we start just creating the traditional class files that you would know, right, from your traditional JVM. And then we have a Quarkus plugin. That could be running on Maven or Gradle, whatever you prefer, right? We have them all. And this plugin, the Quarkus plugin, will create then an optimized jar. Now, what is this optimized jar? Well, we at Red Hat, obviously, we have lots of experience also with server development. And a server, when you take your jar or war, I mean, what does it do? It has to take this and it has to look into this. It has to parse the files. There will be XML or JSON. So all these files have to be parsed. There are annotations that have to be parsed. And yeah, this takes time. And B, obviously, there will be classes that will be loaded and that will be necessary for this parsing and all this setting up logic. Well, the thing is, in a traditional way, if you just have your normal jar and you want this to run this on a traditional app server, then all these classes will be loaded and then they will stay in the memory for the entire lifetime of the application. What a waste, right? So we are trying to do this whole process up front at, we say, boot time, right? So when we create the file, we try to do as much as possible then up front, and we create a recording, right? Or a caching, where we have just the bytecode, which can then directly be loaded into the hotspot VM. Well, this will be much faster, obviously, and especially also because we don't need all these setting up logic, all these setting up Java classes anymore. They will never be loaded into the hotspot VM. So this is smaller, that's why it's smaller, and this is also why it's much faster, okay? Now, if you want to, or have to, because you just need this extra performance and this really small file, you can further go and you can run this also on GraalVM and create a native executable, okay? As I said, it might come with some restrictions, so you have to choose what's the best option for you, right? We support both, okay? So now, well, so far I said a lot about running on production and faster, saving memory, saving money. That's all fine, right? But obviously for you as a developer, what do you care most? Well, the way your daily life works, right? So this should be fun, right? And we at Red Hat, we are also developers, so we also thought about that. We wanted to make this also an awesome, fast experience. And there is a lot that we can show you that will make it fun to work for you with Quarkus. But I will not talk too much here. I will just say, for example, the coolest feature that I really deeply love is the Quarkus dev mode. And I will not explain it. I will just show it to you, because I guess that's just the best way to experience something. So before I start my coding demo, one last word. So as soon as my talk is over, I would really highly recommend you that you go here to this website, quarkus.io, get started. I think this is a super easy way to get started. We have guides for almost everything, and we really made sure to make this an awesome experience, simple to follow. So it's always like this here. One, you need an IDE. You have it, okay, go on. If not, click here, install it. Second, you need JDK or newer. Have it, go on. If not, click here, right? And so on. You need Apache Maven or Gradle. You need GraalVM, and you can just follow that. Also, if you want to develop an extension because you're the maintainer of some framework, we have also lots of tutorials for this. So please go to this website, check it out yourself. This is awesome fun. And the coding stuff that I will show you, you will also find much of that here. And then after my session, you can do this by yourself, right? Because watching me coding is a first step, I guess, but doing this for yourself is probably a much bigger, greater experience. Okay, so now let me start, okay, and show you. So I start with Maven because I really like Maven, but if you prefer Gradle, you can also use Gradle, as I said, okay? So I say Maven io.quarkus Quarkus minus Maven plugin create. Okay. So this is now a dialog that will help us to set up a first sample project, right? I mean, obviously, you could also just create the POM file and the whole project by yourself. This is just a very simple, fun way, I think, where also we are trying to support you and to make the start for you as simple and pragmatic as possible, right? Okay, so let me pick a group ID. I'll take com, Red Hat, developers. Okay, so as artifact ID, let me pick vjug and then hello. Version snapshot, that's fine. Do you want to create a REST resource? Yes. Resource class name, hello resource, that's also fine. Hello, that's fine. And we're done. Okay. And now you see it created the project here in vjug hello. So we'll go there. Okay. And as it says, my application later on will be accessible on port 8080 on my local host. Okay. And here it also tells us already about the Quarkus dev mode. This will I'll show you like within the next minutes. Okay, but step by step. Okay. So now let's open this and have a look. So I go to vjug, vjug hello. Let's have a look. What do we have here? Okay, so you see we have a source folder. There will be the Java sources. We have a Docker ignore file, which gives you probably an idea that we also provide Docker files. We have the POM file. Okay, so let's open the project. POM XML. So this will take a bit of time to load. Okay, so let's have a look at this. Okay, so here we have the POM file. And once this is loaded, source main Docker. So here we have to provide 2 Docker files already for you. So you have it as simple as ever possible, right? This was really important for us to make this simple for you and fun. So this is the Docker file for the normal hotspot VM. And this is the Docker file for our native executable. And this one I want to showcase right now, right? So we want to create a native file. But actually, what means native? I should maybe clarify that. Well, the thing is, you know, with Java, we are used to write once and run anywhere, right? Well, with a native file, this is not the case anymore. We have to choose, like, what system will this be? Like, for example, here I'm running on a MacBook. But if we're speaking of the cloud, we would most probably use something like Docker. And then we would probably have something like a Linux container. For example, here I will use Fedora Minimal, right? And obviously, because of this, it will we will have to create this specifically for a Linux environment, right? Otherwise, it will, I mean, I have to pick, I have to choose. Do I want to run this on my Mac or on a Linux container? Okay. So there's also Java. Let's see. So this was auto-created. The hello resource. This will be accessible on hello, and it will return hello. Also, we have tests. We really care about testing at Red Hat. So here we have the hello resource test with a Quarkus annotation, right? So this is an integration test. We also have an integration test for a native executable. But yeah, we won't find time to show you this one. Okay. So now let me compile that, and then we can run it as a native executable. So I will, no, maybe I should also show you the POM XML, yes. So how does this look like? So we have a BOM, so we inherit all the versions to have this also, again, as easy as possible. Here we have REST easy. That means we have JXRS and a subset of CDI ready. We also have JUnit 5, but you can also use JUnit 4 if you prefer. What else do we have? So here's the profile native. This will need to create a native executable, and we'll do this in a sec. And here are the integration tests, which you can run over the verify goal. Okay, that's all the magic there is. Okay, so let me close this, because later on we'll create a second project, and this could get confusing. Now I will not further continue working on this code. I will just create a native executable for this. Okay, so let's close this for now. And let's go back to the console. Okay, so now let's create the native executable. So this is Maven package -p, the profile native that you saw on the POM XML. And now I need to say -d native. And this part, by the way, this is specifically needed because I want to now create an image for Linux, right? If I just want to run this on here, my Mac, I wouldn't need this part. This is the extra part. So native image dot Docker minus build equals to true. Okay, let's check. Maven package p native looks good. Now, this is a very consuming process. There's also the test running. This can easily take over a minute, right? Because we have to create a native executable. We will use the graal VM for this. This will take a while. And because this takes a while, and I don't want you to wait for over a minute, I'll already start a second tab, and we'll create a second application. And then we'll play around with both applications. Okay. So now let's do the same thing again, just a bit different this time. Okay. So this time I say Maven io.quarkus quarkus minus Maven plugin. And as I'm doing this again, I hope this helps you to remember it already a bit. So you see here, it's still processing on the left side in our other tab. So you see also I'm using version 0.14 of the Quarkus Maven plugin. And now I have to type in again the group ID, right, as before. So com Red Hat developers. And this time I will pick vjug, but main, because this will actually be our main application. Okay, this time I will not create a REST resource. And I'm done. And now let's open this also. But before I do this, let's see if we're done. Yes, so this took a bit over a minute. So now I want to start this, right? So let's see. Let's go to the target folder. Let's first of all check this out. Okay, so here we have this here is the native executable. So anyone in the chat maybe, can you answer me, how would you actually, I mean, most of us probably have never seen a native executable, right? We're just so used to seeing these jars. So how would you start a native executable? Can anyone tell me this in the chat? Okay, I tell you, to make a long story short.
You double click on it.
It's just dot slash. Oh, there is an answer. No, this is something else. Package fails. vjug minus hello, like this, right? But now I can already tell you this is not going to work. Why? Because this is, I just wanted to prove you, this is a binary file, and it cannot execute this because I made this specifically for Linux, but I'm not on Linux at the moment, right? So we have to do something else, okay? So let's go back. Let's say docker build minus f, and now I'm using the Docker file, right? So I'm creating a Docker container now. Okay, so source, main, Docker, and now I can choose, and I pick the Docker file native. Minus t, Quarkus minus demo slash demo, and not to forget the important dot. Okay, so it's already done. And now we can run this. So docker build, docker run minus I minus rm minus p. And now this application I want to run on port 8080, and the other one then we have to remember to run on port 8081. Okay. So that they don't interfere with each other. Okay. So Quarkus minus demo. And now, this was so fast, you probably haven't even realized this. This is the startup time, 5 milliseconds. This is so fast, let's just do it again. 5 milliseconds. This is incredible. But I mean, I might be cheating you, so let's just see if this is actually working in the browser. So let's go, localhost, no, not 8081, but 80, and hello. There we are. Oh, it's already big, okay. So I hope you can see that fine. Maybe let's just do it again. It's so much fun. And I'm just not fast enough, so this is now not working, right? And now let's run this again. But I'm just not fast enough for this. And this is Java. Remember, this is Java. This is just incredible. Go or Node, bye-bye, right? Java, hello. Yeah, okay. So this is cool, but yeah, maybe let's see some more code, right? So now let's go back to our other application and let's play around with the code also. Okay, so the first thing that I want to show you is we have another feature for developers, which is we can add really easily new extensions. And for this, again, we have some support from our plugin. So let me check PVD. Am I in the right folder? No. So I have to go to vjug -main. Okay. So now I say maven Quarkus and colon list minus extensions. There we are, right? So now we see we have a lot of extensions. By the way, I might also explain this. So what do we need these for? Well, if you want to run your application as a native executable, right, then there's different ways of how you can do that. First of all, you need GraalVM, obviously. But before there was Quarkus, you could do this. I mean, you can also do this without Quarkus. The thing is, however, with GraalVM, this is a quite complex process. You have to set up some config files. This can take you a while. And we wanted to make this experience as simple and fast as possible for you. And this is what here we use these extensions for, right? Because they will help you that you don't need to do anything. They will do everything for you under the hood, okay? So I want to showcase some new things also, because there's even more that we have. And that is Panache, right? Panache is a new implementation of JPA. Panache itself is so big. I mean, we could have a talk only about this for like, it would be its own talk for like an hour, right? I mean, we don't have the time today for this, so I will just slightly touch the subject. But I just had to show you this because I think it's really cool. So let me copy this because we will add it to our project. Now I start as maven Quarkus colon add minus extension minus d extensions equals to Panache. But there is more. Let's use some more stuff. Okay, so this was Panache. Now, obviously, we also need some JDBC driver, right? And I have a MySQL database running in the background, so I will use here MariaDB because they are compatible. And it's probably also cooler than using H2. Okay, so what else? Let's use here REST-easy JSONB. And here, SmallRye, our microprofile implementation. Let's use fault tolerance, comma. What else can we use? Let me check. Health. Yeah, there's so much. I mean, I couldn't show you everything here in just one session. But let's use the REST client because we will use that to connect our two applications so they can communicate with each other. Okay. So now I hope I have 5 different dependencies. So this is now done. 1, 2, 3, 4, 5. Looks good. And they were all added to my POM. So let's check this out now. But now we'll switch over to my IDE, and we can continue from there also easily. Maybe that's cooler. Okay, so, I haven't even started this, so sorry. So ls idea pom xml. So now this is loading. Will be looking very similar to before. Only with the difference that I have not added any classes. We'll do this from scratch this time, okay? So as before, we have our Maven structure with source main. We have the Docker files. Here, the Java file, however, is empty. Oops, sorry. And here we have resources. We have the application properties. These we need to because we need to configure to be set up against my MySQL database. So let me add that now. And because I can't remember all of that, I will get it here. So quarkus.txt. And here I can copy this, copy and paste, Stack Overflow Programmer. And now the other application, the native one, is running on port 8081, port 80. So we have to put this on port 8081, right? The test port will be 8083, but I guess we'll not run this just so that they will not interfere. Okay, so now let's create a first Java file. But before I do this, let me start now finally, hooray, with my most favorite Quarkus developer mode. The thing is, you might know similar tools that can do something like this, but there's one big difference. This one will allow us to really work on our code, show a first result, work again on the code. This will hot reload. With one exception, well, A, this comes for free, it's open source, and B, second cool thing is we can even add new classes, right? Before this was never possible, but Quarkus is so fast, we'll just reload the whole thing. You will not notice because this is so fast. Wow. Okay, so let me show you. So now I say maven compile Quarkus F. This is all it takes. And as you see, I'm starting from scratch, right? There is no Java file whatsoever. This started in 1.3 seconds. As you can see, obviously, due before the native mode, this is much slower. It's also slower than if I would have just compiled this and would have started in Quarkus a hotspot mode, right? This is I'm not showing at the moment, but I mean, this is the Quarkus dev mode, and this is the only time that we have to do this, because from now on, we can work in a very interactive way, right? So let me show you. New Java class, com, method, developers, and I'll start with a developer resource. Okay. So first class. Now we need a path. Let's pick developers for this. And we need a method. And you might guess it, probably hello world. So return hello world. Okay, so we need some more stuff. First of all, I will add the path hello here. Second, I'll make this get. Yes, you could also make it post, but we're just really simple and pragmatic here. And then produces media type, here it is, text plain. Really simple, I guess. We can also format this, okay? And we're done for a first try, right? I mean, this is not spectacular. This is just what we had before, with the one difference. We're developing this from scratch and our server is already running. So let's see if this works. So now we should be on the different port, on port 8081. And then we will go to developers, and hello. Okay. So let's see what happens. Hello world. Now, seems like I forgot one thing, right? I mean, there should be an exclamation mark, I think. Wouldn't that be nicer? Now, what do we have to do in a normal application development? Well, I would have to stop my server. I would have to change my code. I would have to compile my code. I would have to wait for it to compile. And for a big application, this could take minutes, or I don't know, some with tests, bad integration tests, probably even an hour. So you would have a lot of time to slacking off on Facebook and Twitter, right? Well, unfortunately here, this is a bit different. All I have to do is I go back, I add my exclamation mark, I go back again, I hit reload, and it's there. And again, this is so fast. I'm not fast enough here. So here we see this was a hot replacement total time of 4.7 seconds. So not even half a second, right? And remember, I started from scratch. I just created the developer resource. It was not existing before. And this works with Quarkus dev mode. Okay, but let's add some more cool stuff, right? I want to show you now panache. So again, new class. Let's say developer, my entity. So I make this an entity. And now you probably know, and we need an entity manager or repository. Well, with panache, things are quite different, right? If you know the active record pattern, yes, that's what we have here, right? So we can just say extends panache entity, and we're done. So what does this give us? Let's check. So I can click here. I see I directly get an IDE. You can click here, and I see there's lots of methods that I automatically inherit and I can use. For example, find or find all. And if you prefer, let me close this. If you prefer a classical repository, yes, that's also possible. We support that too. So we don't judge whatever you prefer. You can make this a repository. It's not working because, yeah, this has to be an interface. I'm not doing this now. Just to show you, you can do this as well, right? And if you want to or have to still use an entity manager, yes, that is possible just as well. Okay. So let me go back. Now let's develop this. Okay. 1 sec, I have to think. So, okay, let's have some coding fun. So, private string name. Yeah, our developer needs a name, obviously. And now let's have some fun with my IDE also. So, with 1 click, constructor, yes, done. And let's have another one, 1 click, select none. Okay, so this I'll make private. This, you might have guessed it, we just need for panache, right? This just like Hibernate was also a JPA. So I add a comment that the next developer knows why this is there and doesn't remove it, just by panache only. Okay, and this, okay, good start. But maybe we can make this even cooler. Refactor constructor with factory method. Okay, of just for the fun of it. And now last but not least, let me add a getter. Okay, so, and we're done. And this is our entire entity. Remember, the ID is already there. This is all we have to do. Now let's use this also, right? So I want one method that allows me to retrieve all the developers from my database. Obviously, in a real productive environment, you wouldn't do that, but we're just here playing around. So I guess in this case, it's okay. Okay, so application JSON, this will be, and we will return a list, Java util list, yes, of developer. So let's call this method developers. And now, what do? We just have to say developer.listAll. Active record pattern. Okay, so what else? Well, this is, I guess, already nice, but will be empty. But maybe just for the fun of it, let's just check it. Is it working? Yeah, it's working, but it's empty, right? So we have to now fill it. Okay, so let me copy this again. Quick. Pass, let's say new. Name. That is still fine. Text plain is wrong. We need application JSON. Let's say new developer. Right? And let's return a developer. Okay. So what do we need? Well, first of all, we need to create a developer, right? So developer equals to developer of. And now I put the name, right? Well, the name is not there yet. I'm too fast. So I need a pass param. Name. And string name. Okay, so this is looking good. Now we have to persist it with 1 click. We're done. And we can return this developer. I'll check. Is this working? Does anyone see a bug here in the code? Maybe you want to type this in the chat. If you're fast enough, I wait, and otherwise I'll just show you. Let's see if anyone finds a bug.
Looks good to me.
Okay, looks good. So let's try this. New, and there we already have Oleg, right? We want an Oleg. I need an Oleg. So, looks good. Now let's see. Where's Oleg? Oleg is gone. So something was wrong. Okay, we forgot the transaction. And I mean, obviously, working in TDD mode, working with tasks a lot is obviously better. But sometimes we make these kind of stupid mistakes, right? And if you made such a mistake, and now you have to reload your entire application server, and you have to wait for ages, this can be really annoying, right? And this is why I love this so much. We add this, and now let's try again. So give me my Oleg. Okay, looks good so far. Give me my Marcus also. Okay, let's see. Ta-da! Now it's working. Right, so some more stuff. Okay, so now really the fun part starts, because now I want to connect. Do you still remember our other application? I want to connect this guy here, you know, the native application, with this application, the non-native application running in dev mode. Let's see if this works and how this works. First of all, we need a new class. I need a client. I call this hello client. Okay. Now, just a REST client. And it's actually not a class, but an interface. Okay. And now I say string hello. Okay. So get produces. And we need media type explain. And one thing is missing. Let me think. Get, we have pass is missing. Yeah. Pass. And here we'll put /hello. Okay, so public interface hello client. Looking good, I guess. So let's try this. This, by the way, you can ignore. This is working. So now private hello client. And now we need to use CDI. So we have to inject that, obviously. And it's our REST client. REST client. Okay, so and now we can use it. So let's remove this. And let's replace this with a remote call of hello. Okay, so we have to return this still. Also, I could leave this bug. Well, let's see what happens. Reload this again, and we have this, right? Runtime exception. Sometimes this happens. But fixed in a second. Turn, all is good. Back, reload. Okay, cool. So now, however, I want to call this hello. And there we have hello, right? And this is coming from here. To prove that, let me kill it. So let me go here, my Docker container, kill it. Quarkus stopped in 1 millisecond. And now, oops, let's go back. This should be gone. It's gone. This should be gone as well. It is, okay? So now, I mean, things like this happen, right? And we should be prepared for that. So now let's add another feature, and that is a fallback. Fallback method. And you see how my IDE supports me. I really like that. On fallback, I'll call this method. Okay, I make this a private method. Private string on fallback. And let's say return hello vjug. Or let's make this hooray vjug. Okay, so let's try this. Hooray vjug, yay! And let's switch back. Running. This time 5 milliseconds again. Seems to stay consistent like this. Hello. Yeah, and that's it. That's all I wanted to show you. So let me go back to my slides. Slides, where are you? Okay, so thanks for watching me. If you now have questions, you can directly ask them in the chat, and we'll see, and I'll try to answer them live. But if you want to have some questions later on, this is also possible. You can follow me on Twitter and ask me also on Twitter. My direct messages are always open. And if you prefer email, old style, you can also write me an email. Besides Twitter, you will find me on LinkedIn. You will find me on YouTube, Facebook, Instagram, whatever you prefer. Okay, and with that, let me go back to Oleg. Thanks. So let me stop sharing my screen. So
yeah, thank you very much. That was a cool demonstration. We have a couple of questions, mostly in the.
Wait, I can't see you. One sec.
Can you hear me? One, two, three.
Yes. No.
Excellent.
Wait. No, wait. It's not working. Okay, I can hear you, and as long as everyone else can see me, that's good enough, I guess.
Yes. So everyone can see you, and they're watching you. The camera is locked on you, right? So
great.
Well, thank you very much. Great presentation. People in the chat voicing the same opinion. A question from Rebecca Rushforth. Interesting to see an AWS Lambda extension in the list. If you could comment on that. Do you need to set up a custom runtime, or how do you run Quarkus?
Okay, yeah, I'm also just reading it. Thanks, Rebecca, for this question. Sorry, can't tell you right now because I don't know so much about AWS Lambda extensions, but I can ask one of our engineers and come back to you with the correct answer. Okay, so yeah.
If you allow me to comment on that, then because
yeah, sure, you are the expert. You're the GraalVM expert, so we have Oleg here. He might be able to answer this.
Yeah. So in general, since I know this from being a GraalVM developer advocate, right? So if you want to run a GraalVM native image in the AWS Lambda, you need to set up. As far as I know currently, you need to set up a custom runtime. Right? You can do that, and then you just point to your executable. And if you search for examples, I can give you some links. I think I've seen an example in Kotlin and an example of like plain Java. I don't think I've seen the Quarkus example, but I think it would be very similar because at the end it's a native executable that you need to package in a specific way. Maybe Quarkus can provide more integration or like an easier user experience, but it should work currently if you tinker with it a little bit.
Yes, Kleber, he has a question about the Quarkus dev mode. He says it's not working on multi-module projects. There are several bugs. Okay. Yeah, well, you have to know, obviously, we're still in development mode, right? Development mode. I'm just talking so much about development mode that, yeah. I mean, it's still under development. It's just at the moment Quarkus version 0.14, right? So there can be some quirks still. I'm sorry. But we're working on that, promise. As soon as we have version 1.0, this will be ready. And yeah, so at the moment, I'm sorry if this is not working on multi-module projects, but I'm sure this will soon be fixed. Okay. You could open, I don't know, you can check, is there already an issue, or you just open an issue, Kleber? Yeah. Okay. I mean, this is open source, just help us.
Yeah. Another question a little bit earlier. Do you know, it's a question from Jeroen van de Velde. I hope I pronounced that correctly. Marcus, do you know if any customers use Quarkus in production? And if yes, at which scale?
Okay, yeah, I'm also in the chat. I'm just seeing this at the site on my second notebook. So I heard there are a few customers in like small cases using this on production, but I can't give you like specific names. I don't even know if they would want to hear this here or not, right? And so I can't give you any specific names, right? And yeah, and scale is probably still small, right? I mean, we ourselves, we don't recommend this at the moment to run on production. Please give us some time. We're really heavily working on Quarkus. We hope, I mean, I can't promise anything, right? It's ready when it's done. But I would personally hope that this is done within the next months, and then we'll also support this. And yeah, then you're happy to use this on production as much as you ever want. Okay.
Yeah. There were a couple of questions comparing Quarkus to Spring framework, but whether there are any Quarkus and Spring examples. Can you comment on that relationship between the two?
Well, Spring Boot is like awesome. I mean, we have used this for so many years, but like Quarkus has been specifically built for a cloud environment, right? And we have there lots of advantages. So it's your pick, which one you prefer or which one you want to use. We think that like in a serverless environment, Quarkus is the way to go for today. So yeah. Now there's Pete. He asks, is there any concern
about holding connection information in a container that will hold state? I'm staring at this question as well, trying to decipher that. But he comments, or they comment further, any security concerns running the container with permissions 775. So everything for the owner and the group. And
well, I'm not aware of any concerns. So yeah.
Again, I think maybe the security concerns would be the same as for any other container or
yeah, I mean that obviously, but I mean not specifically for Quarkus. That's what I meant.
Yeah.
I mean with a container, yeah.
Excellent. I don't think we have any more questions in the chat coming.
Well, if there are more coming, I'll be a bit longer in the chat. So just keep questions coming. I can answer them also offline. Yeah, and if the chat is done, yeah, feel free to reach me on Twitter or LinkedIn or wherever you like, right? Send me an email, would be cool. So thanks for having me, Oleg. Really, again, a great pleasure to be in VJUG, the probably greatest and biggest virtual community for Java. Really fun to be here. So yeah, thanks.
Yeah, thank you very much. I enjoyed the session very much. If you're watching us on YouTube, check out the virtualjug.com and our past sessions. If you are watching us live, stay tuned. Hopefully, we'll have more sessions in May. Thank you, Marcus, for the insightful session. Let's all go and check out Quarkus.io and see whether we can build applications with it and how it feels. Very interesting. Thanks a lot. See you next time.
Yeah, thanks. Bye.
Bye.